next 1 minute. Meanwhile, I'm just admitting everyone who's in the waiting room. Hey, Kaustubh. So just stand by, everyone. Just letting few more people in. We'll start in the next 20 seconds. And yeah, without, as you all can see me in most of the workshops, yeah, just feel free to keep your questions with yourself until the end of the session, or just feel free to just bombard your questions on the chat box and Naruto would get back to you later on. Alrighty, I think you can kick off from here. So, hey everyone, and welcome to ETHOnline 2024 workshop titled Build with AvailDA. Joining us today is Naruto, who will be taking us through the session. And with that, I'll pass it over to Naruto to get the workshop started. Over to you, Naruto.
Hey guys, hope you can hear me correctly. My name is Naruto. This is what I go in Web3. Been in Web3 for four plus years or something like that. Did a lot of dev stuff, did a lot of smart contracting stuff, and then moved to Avail. So I work as a senior DevRel engineer at Avail. And today I'm just gonna show you like what Avail really is, why do we need it, and what you can build with it, what are the bounties, and all those similar things, But yeah, thanks a lot for Eat Global and everyone for hosting us. Really great. A lot of things that happened, or like, me starting in Web3, I learned a lot from Eat Global as well. So definitely gratitude over there. So let's move into the Avail project, what it is, what we are doing. And like I have the messages open. So if you have any text, if you have any questions, please feel free to text there and I'll just look at it. Let's go with it. So what is Avail and how we are trying to accomplish things in Web3? We are basically a unification layer. What unification layer basically means is that there's so many rollups going on at this current in this current L2 scape, like the Ethereum is right now in L2 roadmap on an L2 roadmap. And what we're trying to do is we are trying to scale Ethereum, scale these rollups. Then we have UX fragmentations, and then we have liquidity fragmentation. So there are so many issues that we're trying to solve. So I'm just going to give you a brief rundown. There are slides for sure. Sometimes I follow the slides, sometimes I do not. If you have any questions, please feel free to like put it in the chat. But the challenges that Web3 right now faces is like there are so many rollups. These rollups, basically, if you're familiar with the protocol level, they post the data to data availability layer. So there are multiple layers in a modular ecosystem, or even like monolithic. Data availability is one of the most important one because that's where the bottleneck is, where there's a lot of like costing is. And then there's also like, consensus layer, there's a execution layer, all these, four different layers come up and build a blockchain basically. So here we have a data availability layer. The idea with the data availability layer is that any transaction that goes through, they need to post the data to the main chain and to the base chain. And a lot of times, like Ethereum, when people post data there, they're so expensive that it just becomes like gas expensive for people. And that's why like DAs are needed. So there are like multiple solutions for DAs as far as like right now, which are mainnet, are Celestia, Avail, and EigenDA. But today we're just going to talk about that AvailDA, how it is different, what you can do with it, how we can leverage it to launch your own rollups, launch some app chains, and what you can build with it basically, right? But again, what we are trying to solve is we are trying to scale the rollups through the DA. We are trying to solve the rollup UX fragmentation. What it basically means is that in a landscape of like, let's say 100 rollups, you're moving from one rollup to another rollup and you have 10 different clicks. You go to the bridge first, then you bridge from, let's say, scroll to base or like zkissing to something else. And then there's just like too much clutter, right? So we're trying to like improve the user experience through unifying all the rollups. We'll talk more about that. And then we have like the idea of unification. Like you need to have this rollup composability, which is needed in the Web3 space right now. So the big picture, Ethereum-based rollups, they're the center stage. If you go on L2 beats, you have close to 40 rollups that are live, I think, and then there are like other 40 that are coming in. So in a landscape, let's say 2 years down the line, you see 500 rollups. Like there's always a possibility because people keep spinning up their own rollups. There are always possibilities because people can now do micro rollups, they can do app chains. So there's so much going on. And because of that, there's a need for DAs because dank sharding is like probably 4 years down the line. What do people do for 4 years, right? You need to have a cheap and fast and verifiable way. So this is our idea that because of there's hundreds of general purpose and app specific rollup, we want to solve. AvailDA has a lot of tech, ZK tech, and KZG validity proof. Will go deep into them, but this is the big picture, what we're trying to solve. Then Avail Nexus and Avail Fusion, I'll talk more about it because if I start talking, I won't stop. So we'll just move ahead and we'll see what we're doing. But these are the three products that Avail is building right now: AvailDA, Avail Nexus, and Avail Fusion. AvailDA is basically a data availability layer, which is mainnet right now. We went live on mainnet last month, so that was a really big feat. And then we have Avail Nexus that is under heavy development right now, and we're very close to it. And then we have Avail Fusion. So what is AvailDA? As you know, the DAs are basically data availability, right? DAs has blob space and other things, and all you're doing is posting data. And I probably need to change this one line if you can see. AvailDA mainnet coming, but it's already here. So it was launched last year. But DA layers basically do, a lot of data availability, a lot of data availability sampling. All the rollups basically use DAs to save the cost for themselves and the users. AvailDA is basically a modular base layer. It provides block space to chains, any modular chain, right? So doing any kind of sequencing, packaging, publishing data, it does all itself. AvailDA has like validator sets that will sign on the published blocks and work with its own like validator set and all those different things. That's a different thing that we don't want to talk about, or we do not want to get into too much because validator set or consensus mechanism is completely a different topic. But again, each rollup built with AvailDA is empowered to define how to interpret its own transaction. That means everything is customizable. Then we have AvailDA Lite clients. So to give you a very brief on how the whole Avail vision is and what like these DAs do, I want to explain you a very easy mechanism. Let's say that you have a rollup, and what rollup basically will do is like it will post data, right? And I've been saying this a little bit over the lines again and again, that what actually happens is that there will be multiple transactions on your blockchain, and these transactions will have transaction data. Now this data goes to the Avail. Because this, sorry, any question? Okay, sorry, I was looking at the screen. Now, because this goes to the Avail DA layer, it basically, processes all the transaction. That's the basic idea, but then we have a whole AvailDA Lite clients who verifies the data and make sure that the data is live. So what happens is a lot of people think that AvailDA or like any DA is a data storage. It is not. There's a big difference between data storage and data availability. Data storage, basically think of IPFS, Lighthouse, similar ideas. Data availability ensures that the data is available for the nodes to sync or take whenever needed, So that is the major thing. Now, the features that AvailDA has are, let me see if it's ticket, no. So the features that AvailDA has is that it has validity proofs. So there are a few DA layers that are already up and running. The Avail architecture is a little bit different from that. For example, AvailDA basically has validity proofs or KZG commitments, which are basically very succinct and fast to be verified in order to, like make sure that data is available for these nodes or for these, rollups. So that is one of the biggest thing. And then what we do is something called data availability sampling. So AvailDA makes sure that, the data that is present in the whole network, in the whole AvailDA, it is available for you to ping and then to make sure that everything's working fine. You can verify it. You can verify it through something called light clients. Light clients are basically small softwares which you can run in your phones, in your browser, on a desktop. You don't need to like have a heavy hardware configuration. For example, if you want to run like a full node, be it Ethereum, be it Avail, Solana, you need probably like 64 GB of RAM. You need 2 TB of hard disk for a get node or a OP get node and similar things. What we wanted to do is we want to have this light client network, which does not require that much hardware overhead. So that is why we came up with the idea of light clients. It is a P2P network. And what it does is like it does the data availability sampling, which allows the verification for you without downloading the whole block. So basically, let's say that any chain processes processes one block in 12 to 20 seconds. For Avail, it is 20 seconds. And every 20 seconds, there's a new block, there's more data, there's a heavy computation, and you don't want to run a whole node because it takes too much space, right? So you run an Avail like client, and you basically interact with Avail blockchain without running a full node. That is the point of light clients. Very easy and very simple. Um, what is Avail architecture? So Avail is basically a substrate-based layer. It is not an EVM, and that is why, like, if you ever start or if you ever have like an Avail account, it will never start with 0x, 123 or something like that. It will always start with a 5, which means the address is basically SS58 encoding. And what it means is like, it is a substrate base. Substrate base comes from Polkadot architecture. It's completely different from EVM architecture. But what happens is like why we chose is because it has it is more modular, it is more performant. The block space, you have a better block space, you have a nice sequencing and publications, and then there's like transaction data grouping. There are multiple things that a substrate base layer provides that probably like EVM or like anything else cannot provide. But we basically use AvailDA for that. Overlay P2P light client network, this is what I talked about just now, is that why we need a P2P or like a light client network is because light clients can do the computation, or not even the computation, but like just verify the block headers, which is faster. And then give you a confidence like how much available the data is. Then there's always like verification techniques and then transaction downloading. So the point is like light client networks are faster, and then you can have up to 1 million light clients in a network and everything still runs fine. Light client network, yeah, again, another slide, similar slide, but basically it's a LC, node built from scratch in Rust. You don't really need to like, learn the underlying network or how it works. It's mathematically a little bit different. Basically what happens is it has a DHT, which is a hash table, and it is maintained by the nodes and then the whole network, the whole P2P network, right? But all you need to know is that light clients sample data from P2P, and you don't need to run a full node to do the whole thing. That is the only thing that you need to care about, or you need to learn, or in simple terms, you can say that you interact with the Avail blockchain without downloading the full node. That's the only thing that you can, you need it. So that's that. Then I'll move to Avail Nexus. So what Avail Nexus basically is, and I think, like there's so many things that it is one of the biggest projects that I am very passionate about. And what Avail Nexus does is that it is a permissionless verification hub for unifying rollups, in layman terms. But think of an aggregated layer. What happens is now that you have thousands of rollups, thousands of bridges, because, for example, if you can see in this whole diagram, and I don't know if you can see my cursor, but think of this way, that you have a chain 3, chain 2, chain 1, then you have a light client network, which is completely different, and then Avail as a base layer. Now, because you have thousands of rollups and you need to find multiple routes to one chain to another. For example, let's say chain 1 is base and chain 6 is, let's say, blast. Sorry. Sorry if you heard something. But anyway, so if you have base, if you have blast, and you're moving, let's say, 1 ETH from base to blast, now the bridges that already exist, they need to find a route. That's how bridges work. These are basically essentially smart contracts, and they have routes from one thing to another. But because if in any case there are thousands of rollups, there are needs of thousands of bridges/routes, right? And we are trying to make sure that this doesn't happen, because that is just increasing complexity for end user. And that's not how mass adoption happens, right? So that's why we have Nexus as a middleware. What it basically does is like it is one coordination layer, and it generates a ZK aggregated proof for all the chains and or all the rollups using Nexus, and essentially gives you one proof. You can call it aggregated proof, or you can do anything else. And what happens is like your transactions are much more, or like your user experience is much more seamless as compared to going through multiple different bridges or something else. So yeah, Avail Nexus will act as a verification hub, which unifies role using AvailDA as the root of trust. So essentially, AvailDA is the base layer, and then it uses Avail Nexus as the middleware. And then this Avail Nexus is used by multiple other rollups that are already using AvailDA, or they can choose not to use AvailDA as well. But the point is that AvailDA is the root of trust, and it enables the unified experience. Nexus has multiple features, so no need to know the state transition function to other rollups. You just need to verify that the transaction were computed correctly, and verify a single proof to verify the validity of all execution that could ever be relevant. What the last point means is that you are verifying a single proof in order to verify rest of the transactions that went through multiple different rollups, right? So if in general, right now, if you want to do the same thing, you have to verify multiple different proofs for every transaction. For every transaction, there's a different proof. And if rollups use Nexus, this is not the case. So yeah, Nexus is a permissionless verification hub. As I mentioned earlier, there's a proof aggregation. As you can see in the diagram, you have a rollup 1, you have a rollup 2, and then let's say rollup 77 or XYZ or whatever, right? What's happening here is that these can choose to use Avail Nexus layer, or they might not choose to use Avail Nexus, but the Avail data availability layer is the base layer for them to use. What's happening is that it generates a proof from these 3 rollups and then gives out one single proof. This improves the UX for the ecosystem. Then there's a sequencer selection. If you know what sequences are, you're basically sequencing transactions. And then the inclusion is like coordinated via decentralized sequencer selection mechanism. There's a big debate about, decentralized sequencers and centralized sequencers. You don't really need to know too many mechanics in order to build on Avail, but it's always good to know details or the protocol level knowledge. Avail Nexus is targeted in late 2024. The team is building heavily, but that's going on right now. RIS0 and Avail, you can use RIS0. RIS0 is a ZKVM, which can be used for Avail, and then like do any kind of verifiably compute. Won't go too much into it, but we'll just move forward. Avail Fusion. This is what another product that we have, and this is probably targeted in 2025. But what Avail Fusion does is like it completes the unification layer that we at Avail keep talking about. It is giving you crypto economic security for the whole network. So generally what happens, it's a staking platform in very layman terms. Generally what happens is like for any network to be, very much working or, reliant or decentralized, it also needs to be secure. Secure means like there's enough, enough assets staked, and there can be rewards for the staked assets, and then there can be rewards for the validators and all those different things. So what generally happens with Fusion, Avail Fusion, is it's a little bit similar and a different thing from if you have heard EigenLayer or if any other staking platform. Generally, what happens is like if you were to stake with, for example, EigenLayer, which is an liquid, which is a restaking thing, by the way, you can just stake Ethereum. But with Fusion, Avail Fusion, you can stake Ethereum, you can stake Bitcoin, you can also stake the native assets of Avail, which is Avail token, and then probably like we have a POC where we can stake other L2s as well, other L2 native token as well. So this is all you need to know. It's more there for the crypto economic security rather than anything else. And then it also contributes to the consensus mechanism. Consensus mechanism are a little bit different in Avail. We'll go over that as well. And yeah, so that is, just a basic idea, but I want to explain you a lot of different things on what you can build, how you can build it. But those are like the major questions. Any questions so far? Okay, I have 4 minutes, and what I want to show you right now is basically, let me stop my screen. Second. So that I can quickly give you a demo of what you can do with Avail or what you can build with Avail. And this will be basically, I cannot see the screen. Weirdly, for some reason, I cannot share the screen. Let me try one more time so that people know what's going on. This is a little bit important stuff. Okay. If I hope you can see this.
Yep, we got you.
Okay, good. So this is very basic, explorer.avail.so. .so. I'll share the link with you. These are all in the Ethereum thing as well. And here, what you're basically doing is this is a test net. There are multiple accounts. There's network. There's developer thing, which is the most important thing for you. So think of this way is data availability. So you go in here and then you select data availability, and then now you're trying to post data to the Avail blockchain. And you can select submit data, create application ID, and anything else. So we'll just go and do like a submit data, and then we'll just see an example of how the submission looks like. And then, like if anyone else has a question, I'm open to that. We'll just go, this is ETHOnline hackathon. And you can see there's a bunch of things coming in here and there. And what I'll do is I'll do a basic submit transaction. So you can see there's a piece of milli Avail. and then there's like my account, there's an app ID. The idea of app ID in Avail ecosystem is that you need an app ID to whatever you're building so that everything can go through this. So you can choose 0, you can create your own app ID. It's basically a number that is related to your project, your rollup, or anything else. And then we do sign and submit. I need to password. So we do this and we approve. And then when you get it approved, it's gonna get approved here, but we have a networks tab here, which we can look at, and we'll be able to find that similar data that is submitted here. So this is the network tab, and then this is the Explorer. So think of like Etherscan, but it was, it is a fork of Polkadot.js. And what's happening here is like you can see my account here. There is the data, and then what we can do is we can deep dive into it on what's happening. What is the data submitted? What happened? The data availability data submitted. So this is the hash code. There are balance deposit, how much money that I spent, how much treasury was used, and then similar things, right? So you can do multiple things with Avail Explorer to understand, but there are also like documentation or the GitHub repo that you can look at. So very quick, I'm gonna go to Avail.js. It's in the Avail project /Avail, and here you have examples. So if you want to run like some JS examples, you can basically look at these simple things. So, like the transaction that we followed just now, that was like a data submission. So you can go in the data availability, data submission tab, and then you can, see the code, what's happening here. There's some API.txt data, availability.submit data. This is the important line that actually does it. And then, like you can do other functions as well. So that's a major thing. Quick question to Kelvin. Do we have enough time?
Yeah, Calvin had to jump into another call. I take over from here. So I would say we can have another like 5 minutes for you to go over the bounties maybe that you
Yes.
guys are offering.
Yes.
And then have like a quick Q&A if there's any questions. So for anybody listening, attending this one, if you have any questions, just post them in the chat and we'll go through them one by one.
So I think I can look at Avail's bounties here. So basically build with Avail, it's a pool price. Whatever you build with Avail, you can use risk zero, as we talked about. You can use Stacker, which is a micro rollup. You can use Avail Light Client P2P to build something else. But you can build anything with Avail if it's related to app chains or rollups. So that's one of our bounties. There's a hacker cheat sheet. There's an Avail Explorer, which we just went through. There's another Explorer, which we use, which is called Subscan. And then there's the documentation. And there's best use of any rollup SDK with Avail. What it basically means is that we use Arbitrum Orbit, OP Stack, and then we also add like a lot of we have integrated with OP Stack and Arbitrum. So anyone can use these stacks and build their own rollup. So we have some of these things where you can come up with your own idea of a rollup and what it should do. And once you launch this rollup, you'll be able to make these things possible, So that's that we have it for Polygon CDK. We have micro rollups with Stacker. You can do an NFT marketing rollup. And then there's a liquid staking for Avail as well. So there are like a lot of things that you can build with Avail. And then finally, there's like best code tooling project. So any code tool that improves the Avail ecosystem, for example, an efficiency cost calculator, some kind of visualizer, some dashboard, or like, telemetry thing, all these things also qualify for it. Those are like the major things. Okay, that's just me. And yep. So these are like the, bounties. We're here to like help you guys. If you need anything, you can text us on the Discord. I'll put in my Telegram here. If there is, that's okay, right, Kelvin or ETHOnline?
Yeah, that's okay.
Yeah. So this is my Telegram and this is my Twitter. if you have any questions, just ask me, and I'm like, I can reply to you right away. So just, if you have any questions, and if you need, Avail test tokens, faucet, I can send you right away as well. But thanks a lot for having me, guys. Best of luck for your hacking experience and hackathon.
Thank you very much. That was great. Naruto, really, really appreciate it. So I would open it up for like another 2-3 minutes for a Q&A. So are there any questions? I haven't seen anything in the chat. If not, we can end this right here. And as Naruto mentioned, you can reach pretty much everybody from every single sponsor, also in the Discord. So if you're not sure, if you don't want to speak out yet, that's completely fine. You can reach pretty much everybody throughout the entirety of the hackathon. Okay. No, there we go. Yep. Thanks for the Twitter and Telegram handle. No, I think we're good on this end then. Then again, thank you very much, everybody, for attending. Thank you, Naruto, for presenting. Excellent call. And have a great day, everybody. If you're still not sure what to build or don't have a team, there's currently a session going on with Kelvin about team forming, just like a little bit of getting to know one another with a bunch of breakout rooms happening now. So you can join this one as well. The information is on the Discord. Thank you.